For today, so today what do we got? I think we have like definitely a valid Sudoku. So this is just a medium Leetcode question. Let's see how we get to it. So I'm probably sure you know what a Sudoku is. If it's not, Sudoku is basically a board game where all columns for every column, the columns probably for a 9x9. That means that for all the columns, it can only have an extent 1 to 9 to get in each of those columns. So in column 1, you can have a repetition of any of the numbers from 1 to 9. Same as column 2, you can have a repetition all up to column 9. And the same thing applies to the rows. That means that for row 1, you can have a repetition of digits 1 to 9 in row 1 or for any of them in row 2 and so forth. And in the boxes also, the 3x3 boxes in within 2, it has to be 1 to 9. So there cannot be a repetition. So they basically want us to check that so far with what they have right now is it valid or not. So as you can clearly see, this is a very new problem. I have not even attempted it before. You can see no submissions yet, and this is my account, so I have never solved it before. So so how do we go about it, not to waste anyone's time? Yeah, so they're just saying that it can be partially filled but not necessarily solvable, which means that we just have to check that for the values that they filled in so far is the valid. Clearly, I think in this example here, just by looking at it, it looks like everything is valid. I don't see any repetitions in any of the columns or rows or in the boxes. So yeah, true. Let's see a second one. They said false in the exception of 5 in the top left corner. With the exception of 5 in the top left corner, that was modified to 8. There are 2 8s in the top left. Oh, that makes sense. Cause see here, see the 3x3. Oh no, I don't know if I can highlight, but see 1 2 3 4 5 6 7 8 9. See in this 3x3, there's a repetition of 8. So it makes sense that this is not a valid Sudoku. So that is true. But I think aside that, everything is right. So that's why it's invalid. Yeah, and these constraints and stuff, and it's labeled in the Leetcode medium. So basically the idea what I'm thinking of basically right now is just to go through the board, because I mean you sort of have to check through the board to make sure, but probably in the end, if we check through the whole board and we have still not probably returned a false, okay, let me just rewind a bit. 2 things are just coming to my mind. First thing is like, okay, probably have like a list that keeps all the columns. So let's say a list of columns that will probably keep all the values of column 1, all the values of column 2, all the values of column 3, or same for like a list that keeps all the rows as well, and another list that keeps all the boxes as well. So you probably just do a first loop through the whole thing and actually push everything into these boxes and then into this list, and then after you later check each of these, like in the row list, you check each of the lists in those rows to see if there's a repetition in any of those sub lists. So let's say for instance you have like these rows, you keep there's row 1 in like the list of rows, row 2 in the list of rows, row 3 in the list of rows. You keep all of them in there. You do the same for the columns and you do the same for the boxes. Then after you're done, now you check the list of rows for each of the sub list, which is itself a row of elements. You check if there's any repetition in that list. So you probably just do something that checks like, oh, if the list equals sets of that list, because if it's equal to the set of that list, then it should be good. But if it's not equal to the set of that list, then that's probably a problem. So, or yeah, so basically that's that. But that way I'm thinking it could be a little bit slow or flawed. Not flawed, but it will be a bit slow, probably on time complexity, because then first you're looping through everything first to check, and then after you're looping through all your rows that you stored in the list of rows, all the columns in the list of columns, all the boxes. So how about while we're doing the loop through this element already, we make our check at the start. Like we make the check at the start, like not at the start, wrong language, but like as we're checking or as we're looping through the board, we actually check if there are any violations. And that means we need to see if probably we've seen anything at any point in the dictionary, in a dictionary or a hash map or something that can help us look up in a quick time. And obviously our minds can go to a hash map. So maybe we might want to use a hash map for this case, where I think for the plan of this hash map, we start by as we're going through the, like for instance, we'll have a hash map where how do I call it, like let's say we have a hash map called scene, which is something like this, and then let's say the first like for the first row, for row 1 element here, it will have it as 5. So probably we'll have like, oh okay, so row 1 something called row R1 5, something like that, and it will be equal to 1, which means it's been seen already in the list. So, so R1 something like this, so R1 and a hyphen and a 5, which means that it's been seen already in the list. So, or we can even just do R1 5 because the digits are just 1 to 9, so it's just going to be single digits, so we don't even need to do this. We can just even do this, even though people might think it's 15. We know it's not 15. So but just to like make it clean and everything, we can just add this to just make sure that it's good to go. And then if at any point, because as we go in this row 1, we'll keep adding stuff, so we'll probably have R2 the same R row 1, so it'll be like R1, so we'll have another one like this, R1 maybe, and then the value at the row 1, the next one, which is 3, and then we know that one is also 1. So if at any point in R1 we pick another number and we're trying to push it in our dictionary and or in our hash map, and we already know it's in scene, at that moment we already return false. So we don't have to push everything first into a list and then later check. So as we're already looping through the whole board for the first time, we're already checking. So by the time we are done looping through the whole board or going through the whole board or traversing the board, we know that we are done. So if we're done and we did not return a false at any point, we just return a true in the end, you know. So I think that's just the basic plan. So we have to find a way of kind of pushing each of these row elements, column elements, and boxes elements into our Sudoku board. So probably that's gonna be like the only challenge, but aside that, I think it should be good to go. But yeah, so this is my first time, so let's see if I can we can work out something. So basically we have our scene dictionary or hash map, and this is just gonna be in Python, but let's see how to go about it. So let's just call this so rows. Normally if you have something like a board or something, you normally want to call your rows and columns or something like that. So rows would just be, you know, it's just the line of the board, and then you know your columns is just gonna be line of, because it's a 9x9, so it's probably an m times m, but it doesn't matter. But you can just still call it len of, just to make things easy. Yeah, I mean, you can still call it len of board again. And normally, just for the sake, because sometimes you're not always gonna get like an m by n, so normally I just do len of board 0 just to make sure that I'm safe. Yeah, so columns is that, and so we have it that way first time. So what we have to first do is obviously we just check. So for R in rows, for C in calls or columns. Now this is where the main part of the work comes. So we know for rows what we said according to our first plan is we check. So let's say we first make like rows as we said. So row 1, like rows starts from 0, so we could probably, rather than making R15 would probably be R05. So we'll first put R05 and then C05 and stuff like that in there. So we don't have to put it every single time in there, but yeah. So we know that for this one in the column here, we know in this case here we're gonna have string to input. Okay, strings to input. That's strings we want to put in dictionary. Okay, so strings to store. I'm not going to variable name it, but We know strings to store will be something like in a list. We probably put them in a list, and we know that the first one is just gonna be the row name. So basically we know it's R, so we just say string R. We know it's string R plus, so the first one is string, God, I'm getting a little bit confused, but we know it's the first row here, and then that string, so that we store that as a string. So string R, that's the first row, plus yeah, because this is row 1, so we know we have row 1, so string R plus the string number, so string RC, so string RC, string into bracket board RC. So we have this string this plus, we can keep our hyphens if we wanted to, but that's fine. String that plus hyphen plus string board RC, so that we know that for this instance, we know it gives us, like for instance, it will give us the 0. So we for this row 0, so it will be row 0 5. So this one would have like for the first row, or the 0th row as you'd call it, 0th indexing, will have just 0 R. What did I just say? I just confused myself. So 0 5, so 0 hyphen 5. So we'll just have that one, but we should have R as a number like this. So no, R as a word, so it'd be like R plus string R, which is row R0 hyphen the value, so 5, like this. So strings to store, this would be the first one, and then this would be the second one. We know that because this is just the first row, but we also need to keep the column as well. So we know it would be column, so to be, so it should be C for the column name plus the, so string C plus the hyphen, as we said already, and then plus, we know this column too is this column is yeah, we know that we'll have board RC again, because we still, so this time it's gonna be column 0 and then the 5 again. So we have that, and we have string, and then we have board, and then we have R, and we have C. So this way we have this board RC. So these are the ones we're gonna have for that. But now we need to have the string for the boxes as well. So we will just call, yeah, we'll just have these strings to store, and then we'll say box string as well. So we just call a box string, and it will be a string that we're able to get from the, we'll have another function, our helper function, that helps us to calculate the how to also calculate the box. Because like, let's say if you're in this box 1, we should be able to put you in a certain box. So we're like, okay, box 1, or let's say box 0 5, box 1 7, box 2 6, box 3 8, something like that. So we can push the boxes through. So probably be self dot let's say helper, something like that. And this one is probably going to take the row that is in, the column value that it is, and then the yeah, I think it just needs these two. So we'll probably just need the the row and the column, and then the row and the column to put that box in. So that should be fine for that one. And then so while we have that, we just check to see if yeah. So if we like just to make sure we can just push strings to store. So we can just check that for we can just check that, but I think for string oh, why did I just call it just string? Like, this is supposed to be str. Yeah, that's why it wasn't working. Str, sorry guys. Str and then str. So we know that if for string and strings to store, at that point we just check if string is in scene already, because if it's already in scene, then what we have to do is we just have to return false. We don't have to wait anymore, because then we know it's already, we return false. But if it's not in scene, then we just to make them basic programming, but I mean, we don't need to do that. But else we just store that string. So we just say scene string equals 1. We set it to 1, probably just like we've seen or something. So this is basically it. And then what we do is we just go on. So we keep going on and on and on. It will probably go through everything, and then by the time it's done, if it doesn't see anything else, it's just gonna return true if we don't see anything else. So maybe I'll probably go through it to just make sure that the code is right for everything. But let's define our helper now. Define helper, which is just takes self, it takes some row, it takes column. So these are the values that it takes. So to just know what kind of box to put it in. So we say box string equals that. So what we have to actually make sure is that just reminded me. What we have to make sure is that as we're going through these rows and columns, we have to just make sure that, because it will see some empty spaces, and if it sees an empty space, that's just going to be filled with like a dot, as it said. So if it's a dot like this, it might return false. Okay, so it might see multiple dots in a box like this. So we have to just make sure that what we're seeing is not a dot. So what we're supposed to make sure to see is that we just have to make sure that we're not seeing a dot. So we have to kind of make a check for that. But as we're going through this, imagine we were to see a dot. Yeah, if we just need to make sure that we're not seeing a dot, because if we see a dot, we're sort of wasting our time. So we probably want to skip to the next thing. But yeah, so I think all we just have to do is if board RC, I think it already give us, it's already given them these as our values here in string. So we don't need to convert board RC. I thought they were integers. They're just strings already. So we don't even need to convert these guys to like strings anymore. Close board RC here. That's true. So we don't need to convert them. But yeah, we will. So yeah, if board RC equals to full stop like this, what do? We just continue. We don't even look through it. We don't try and go through this whole thing. Just go to the next statement or whatever, like the next cell. So we probably in this thing here, we're just gonna, we know our final value we want to return is return box string. So in here, what we first check is we check for the row and column, and we have to place them in boxes. So probably we can see that there are at least 3 main subcategories from when depending on what R and C is going to be. So we know if our column is between 0 and 0 and 3, that's is between 0 and 2, is from anywhere from 0 to 2, then what we need to do is that we know it's probably going to be in either box 1, box 1, 2, 3, 4, or box 7. But in terms of 0th indexing, we know it's going to be in box 0, box 3, or box 6. So we check. We first do those checks. If we check for the column first, so if 0 less than or equal to column, but it should be less than 3, so probably less than or equal to 2, do something. Yes, and then we say if let's say 3 less than or equal to column, less than or equal to it has to be less than or equal to 5, pass through something. So else it'll probably just be the last one, but else just you know what it is, but we'll probably also do something here. And then, but like now let's go to see what we actually do. So in here, if it's between 0 and 2, we check now, because then we know it's going to be in either this one of these 3. So this one, or that one. So we just need to make sure what our row is also. So we check if 0 0 less than or equal to row less than or equal to 2, less than or equal to 2, we know it's in this we know it's in here, so we just say box string plus or equal to, we just add into the box string. So box string plus or equal to we know what box is supposed to be in, so we just call it, you know what, actually we can just make this easy by not doubling box 1 to week, because now we just make it long. So we can just call it string box, or we can, why not even do this, because it's always going to be empty anyways. Box string equals box plus what else are we putting in here? We know it's gonna be, why we don't even want to call it box, we just need to call it B, and then we can call it the row column thing, whatever row column it is, and then the value. So B plus hyphen plus, actually because we don't even need to do that, because that would just differentiate them, but we don't need to do that. If it's that way, we just call it box 1. B1, so B1 plus the value in there, so plus board. Okay, that means that we need to sort of push board in there. So it needs to push board in there as well. So board RC, so that it knows it's called B1 RC no matter what it's in there. So elif 3 less than or equal to R less than or equal to 5. We just repeat the same thing here, but we'll probably just call it B2. Ctrl C, V, just call it box 2, and then we just call else on this last one here, else. We just call here B3. So we'll probably have the same thing going through for all of these guys here. And then oh no, because this is just from 0 to 2, column from 0 to 2, so it can't just be B1, B2, B3. It has to be B1, B4, and B7. So B4 and then B7, and then we probably continue the same thing for the other ones like the same approach, because if you're from even near column 3 to 5, you're gonna be from anywhere from row 0 to 9 ish, or 0 to 8. Sorry. So what you see, just do similar thing. We just but right now we'll just call this one B2, B5, B8. So we just call it B8. So this one like the same thing here, and then the last set is gonna be something similar. We'll just call it B3, B6, B9. So we'll probably have something like this, and then we'll just return box string. So basically that's all we do. So yeah, so we'll have box string returned, and then yeah, so at least if at any point in the board you have RC, will continue, and then yeah, return false, else string plus equal to 1, and then we do the same thing for the box string too. So yeah, but that one too we can check. So yeah, if box string in scene, return false. If box string is scene, return false. Or we know we can just say scene box string. Okay, this one we can just put the hyphens here. We can just put the hyphens here so that it just matches everything. So yeah. So here, just return this hyphens. Okay, so we have our hyphens here, and then we just go to box string equals. It just feels weird talking to myself, but I hope it makes sense. But this is not like a really hard question. Seems not, hopefully, when I run it. So box string to be 1, probably just like that. And then we go to this thing here, and if it doesn't have it returns true. So yeah, I think this should do it, I guess. Honestly, it really should, because yeah, should probably do it, because this is really it. Ouch. Yeah, because for instance, if this guy here is in row 0, but it's in column 0, 1, 2, 3, 4, so probably in column 4, so it will be somewhere in here, but then in row 0 to 2, so it will be like board 2 plus board 2, 7. So yeah, it should make sense. So hopefully, I know there might be some errors somewhere, which will probably be related to like some syntax error or something. But yeah, let's just run it and see what goes on, because I'd rather see my error. Yeah, I figured out. So for string in string store, if string double N, makes sense. Return false, makes sense. Let's see, int object not iterable. Makes sense to here. Range rows, true. That makes so much sense. Yep, the brush. Probably need to correct a ton of errors before this thing works. So yeah, okay, returns true. Let's run it through the next example just to make sure that everything is going all right. Oh no, sorry. What if the board is empty? I didn't even consider that, but we'll let's see. Hopefully not. Privy. Did it do it? I did not do it. No way. Let's try this. Come on, guys. Oh, it won't let me. Oh, God, I forgot. True. Let's run. Please work. What is going on? Why are they saying that? Invalid test case? So wait, how were their test cases? Hold on. What is going on? How was their test case? Because then I'm confused. How did they have their... Oh, so what is going on? So they had 537 da 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 da, and then the next one da 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 da. So that's basically it. So why? Okay. Oh, so they literally had the same thing. The only thing was that in this one, as they said in the example, they just changed the 8. Modified to an 8. So let's just change the 8 there and see what happens if it will give us a false. Yeah, it gives us a false. So at least we know we're lucky. Let's run it and see. I probably feel like that's gonna be like some issue. Probably have to fix. Oh wow, good. So this is it. Probably not the fastest way, but I know it's definitely better than the first way that we thought about, or like I thought about that. Oh hey, let's go through everything and push everything into a list, and then now we check it. But now at least for sure we know that as we do our loop through the board, at least as long as we're done looping through the board one time on our first traversal, we're gonna have our answer. And I know it's better than the first way where we first loop through the board at first pass just to make sure that we get everything in some list, and then now we check each of these lists, because then now we have to now check all the list of rows that we made up, all the list of columns that we made up, and then all the list of boxes as we made up. But this is definitely better, even though it's probably not the fastest. Trust me, people probably thought about way crazier ways, but you know what, this is good. And thank you guys for joining in, and I hope it was very self-explanatory. And this is like my first video of something like this ever made. Let me know what you guys think and how you guys feel about it. And want more videos like this, honestly, I will post. So I'll try more. So thank you very much, guys, and have a great day.